Okay, question 1. So set C has 127 proper sets. Find NC, the number of elements of set C. Well, we know that the number of subsets of a set with n elements is given by 2 to the power n. And we know that the number of proper subsets it will have is 2 to the power n minus 1. So if we equal this to 127, we then just need to solve that equation to find n. So if we add 1 to both sides, we end up with 2n equals 128, and n is going to equal 7. Number 2, find the number of subsets of k. Now k, how many elements have we got? We've got 5 separate elements, so we must have 2 to the power of 5 subsets, obviously 32. In B, find the number of subsets of k which do not include 7. And so the simple method here is to remove 7, say, right, how many elements have I now got left? I've got 4 elements, so 2 to the power of 4 is going to give me 16 subsets that don't contain that 7. What we should also realise then is that there are 16 that do not include 7, but then there are also 16 that do include 7. So there's always an equal amount of sets that include a certain element or don't include a certain element. And so we can use that actually in C. It says find the number of subsets which include A. Well, we do a similar thing. If we remove A, that means that we've got 4 elements. So 2 to the power of 4 equals 16, and that is the number of subsets that include A and that don't include A. So we can use the same method. In part D then, it says, find the number of subsets of K which include both A and DW, so slightly different now. What we're going to do in this case is, as we did in the cases above, we're going to remove those elements A and DW, and we're now left with 3 elements in this set. So how many subsets can we make with those 3 elements? 2 to the power 3 equals 8. Now what I'm going to do is list all of those subsets. Okay, so those 8 subsets are listed now. You don't need to do this. The reason why we're doing this is just to highlight why this works. Is that now we've got 8 subsets, and none of those subsets contain A or DW. But what it means is we can now put A and DW into each one of these subsets, and we create 8 unique subsets. So we can't create any more than those 8 subsets that contain both A and DW. Part E then sounds similar to D, but there's a significant difference. It says find the number of subsets of K which include 7 or DW. So that means that it includes subsets that include a 7, but not necessarily DW. Subsets that include DW. And subsets that include 7 and DW. Oh, let me just rub that out. So there's 3 separate cases. So what we're going to do is use exactly the same method. Is we're going to remove 7 and DW from our list of 5 elements in the set of K, which means that we've got now 3 elements. And with those 3 elements, we can make 2 to the power 3 subsets. So we can make 8 subsets that don't contain 7 or DW. And then what this means is that firstly, we could add 7 to each one of those subsets to make 8 new unique subsets. We could then add separately DW to those 8 original subsets to make another 8 unique subsets. And then we could add at the same time 7 and DW to those 8 subsets. So what that means is that the 3 cases give us 8 plus 8 plus 8, 24 subsets that contain 7, DW, or 7 and DW.